Good afternoon, everybody. Welcome to another wonderful afternoon of Chem 170 with your host, me, Dr. White. Wow, it's cold and windy out there today. Fall, almost winter. But anyways, let's wait on that for a while, the winter. All right. As you know, over the weekend, I finished grading test number 2. You should have seen your total score in D2L. You should have also gotten an individual email with points for each answer. What I'm going to do today is go through test number 2 of all the answers, but I will cut it out of the video. I like my special effects. Cut it out of the video. Someday I'll really bring a scissors. And if you can't come to today's meeting, Zoom meeting, and you want to see the right answers for any part of test number 2, come to my office hours on Tuesday and Thursday from 6 to 7:15. If you can't make it then, email me and we'll see if we can set up a Zoom meeting so I can help you out. Now, overall, everybody did pretty good. I don't know if I scared you or not, but test number 2 historically has been the lowest average test of the semester, but a lot of you did well. And overall, the class did quite good, which makes me happy. So without further ado, let's go. Any questions? I don't know about you, but I'd have a question. Well, we've taken 2 tests. What's my grade in this class? Well, let's find out. There are 2 methods to determine your grade. Let's call method A. If you take the sum of your 2 tests divided by 2, you'll get a number Z. If that number is 90 to 100, you're getting an A, 80 to 90 B, 70 to 76 C, 60 to 69 D, 59 lower F. Now, since I allow the lowest test to be dropped, there's a method B to determine what grade. And you look at your 2 tests, take the higher score, and if it's 90 and above, you're getting an A right now. If it's 80, 89 B, 70, 79 C, 60, 69 D, and below 60, 59 lower F. And that's the way. And that's because I'm assuming you've handed in all your labs. That's an assumption to use method A and B. And if you have, most of you have gotten very high lab scores. If you don't hand in the labs, well, you're going to have some serious difficulties. So please hand in the labs. Any questions? Going once, going twice. All right. Before we go on to carboxylic acids, did any of you happen to pick up a bottle of vinegar and say, oh, this contains acetic acid, a carboxylic acid? Did any of you happen to pick up a bottle of ketchup, mustard, relish, the good Chicago kind that glows in the dark, the super bright green stuff? I love that on my hot dogs. And think about that contains acetic acid, which is a carboxylic acid. Did any of you happen to pick up a jar of pickles and look at the label and see the liquid that the pickles are in has vinegar, which contains acetic acid. Remember, organic chemistry is all around you. I stole that from SpongeBob, and it won't hurt you to think about it. Oh, that reminds me, I gotta open, let me close one thing. This I don't need anymore. Let me open up the chapter. Anybody bite into lemon or have some limes? There's a nice restaurant, Mexican restaurant near my house. Used to be another restaurant, and they opened up I guess that place went under or sold. They opened up a new place. It's been there for a while. I finally went there this Friday and with a friend, and boy, it was really good. And we had limes. Do you think limes have citric acid in it to make them tart? All right. I believe we ended up, and I did one example, and let's do some more, go back. It's always good to go back and look at the reaction of a Grignard reagent with carbon dioxide. And it's a way of making carboxylic acids. And the reaction is if we take a Grignard reagent, look for what's different. R group carbons, hydrogens with MgX, X can be chlorine, bromine, or iodine. This attacks the carbon here of the CO2, like carbonyl carbon, which I showed you. And the second step acidifies that, and you get a carboxylic acid that's one carbon longer than the R group you started with. Now, this reaction, I'll be very nice to you. I'll never give you a synthesis problem with this. That's a little too difficult for this class, but I will do the following. Since we've already done this, oops, I forgot something. Since I've already done this, I'm going to let you do this first, and then I'll do it. Your turn. What would be the organic product or products for the following reaction? 3 points each. And when you're done, give me a thumbs up. And we'll wait for everybody to finish. Everybody's finished. My turn. So what do we have here that's different? Carbon, carbon, magnesium chloride. It's the Grignard, where X can be chlorine, which in this case it is, bromine, or iodine. And we're reacting with CO2 Second step, acid and water. This attacks, you form a carbon single bond to make a carboxylic acid that's one carbon longer than the R group we started with, and you get that carbon from the CO2. What's R? Ethyl. Therefore, I'll draw my two carbons. I'll add this, my extra carbon, which is double bond to oxygen. It also has a hydroxyl group. I know there are 4 bonds to carbon. Anybody have any nightmares with Halloween coming up? Dr. White going 4 bonds to carbon. I hope not. And that's the product. Oh, let's do another one. And here's another one for you to do. Give the organic product or products for the following reaction. 3 points each. Thank you, Cristiano. We'll give everybody time to finish. Everybody's finished, so it's my turn. And if we look at this molecule, what's different? What's not carbon? What's not hydrogen? Ooh, magnesium bromide on a carbon. And what is that? A Grignard reagent, where X can be chlorine, bromine, which it is in our case, or iodine, those halogens. And I'm reacting with carbon dioxide. Second step, acid H plus and water, H2O, and you get a carboxylic acid that's one carbon larger than the R group you started with. Well, what's my R group? This ring with a methyl group. And what you'll get is this ring with a methyl group. The carbon that had the Grignard will be attached to my carbonyl carbon. And that's how you do it. Now, one of the things why I use this example, I can't think of an easy way to make that molecule without using the Grignard. It'd be quite very difficult and challenging. With the Grignard reagent, that's a piece of cake. Because how would you make, and now you're going to see how organic, synthetic organic chemists work. How would you make this compound? Well, it's a Grignard. You would start with, in this case, what did I have? Bromine. And you'd make this Grignard. And if you had an alcohol, you could react with HBr to make that. You could make the alcohol from the double bond if you couldn't buy the alcohol. And that's how an organic chemist thinks when he's doing synthesis. You work backwards until you can buy what you need to use. Then you buy it instead of working backwards. If you can't, you keep on working backwards. Without using the Grignard, I don't know how I would work backwards to put that carbonyl with the hydroxyl group on there. And that's carboxylic acid. Oh no, guess what time it is? It's new functional group time. It's time for something new. And what is that new thing? Carboxylic acid derivatives. Now, I'll never ask on a test, what's a carboxylic acid derivative? Well, that's a compound in which hydroxyl group of a carboxylic acid is replaced with various other groups. So you make from the carboxylic acid different things by removing the hydroxyl group and replacing it with something. Now, this part of this chapter, we're getting some good things, but I have to tell you a personal story, which I'm not too proud of from my high school days, but you'll have to wait. Well, getting some really neat stuff in this part of the chapter. So let's look at these derivatives. If you replace the hydroxyl group with OR, and another way of writing it would be like this. Instead of OH, we have OR. Excuse me. This is called an ester. Again, this can be made, and I'll show you, from carboxylic acids. So that's why it's called a carboxylic acid derivative, something made from carboxylic acids. And this is called an ester. Ooh, it reminds me of quick story time. I teach the same course. It's called Chem 1212 at College of DuPage sometimes. This last summer I taught it there. But years ago, I was teaching 1212, and I had a student. This is when we were face to face, obviously, years ago before COVID-19, thank God. But anyways, I had a student, the only time I've ever had it in organic, and her name was Esther. And this chapter she didn't like. Why? Because every time I said, well, we'll take this ester, and her head would snap. Did you call me? And it was funny. She was glad when I stopped talking about esters, because every time I said the word ester, she thought I was calling on her. I wasn't. Very nice student, very good student, but it was funny. See, the first time I said that, her head, what? You calling me? All right, now, if you replace the hydroxyl group of a carboxylic acid, this with a halogen, where X can be chlorine, bromine, you know the drill, or iodine, this is called an acid halide. And the ones you've already seen, one is chlorine and acid chloride. Unfortunately, this semester I had to make choices of what I would spend more time with. And I thought, since all of you are not going to be organic chemists, I'm going to spend more time on things that are important to you later on in life and also in your career, like fats and oils, carbohydrates, and proteins, as opposed to I had to drop acid chlorides or halides. We're just not going to talk about it. Now, let's talk about an ester. An ester, which my software likes drawing this way, is made from a carboxylic acid where you replace the hydroxyl group with OR prime, oxygen with carbons on it. And this is called an ester. Now, if I look at the clock, whoa, we got time just to briefly go into, let's go to my whiteboard. All right, everybody see the structure on your screen on my whiteboard? What's different? What's not carbon? What's not hydrogen? Should get your attention like that. Oh, look, we have a carbonyl group. And that's carbon double bond. It's an oxygen. It has an oxygen also bonded, and that carbonyl, that oxygen bonded to carbonyl, we have carbons. So we have this general structure, and this is an ester. And if we look at the clock, let's take a break, a little longer break. I can give you an extra 30 seconds because this way I just won't go on. I don't like stopping. We'll come back and you'll learn the IUPAC rules, how to name esters, and a whole lot of other stuff today too. So with that, come back. Oh, it's now time. Come back at 1:55. I'll see you in 5 minutes. I can get up and stretch. Time to get going. All right, we're talking about esters. And on our screen right now, everybody see the ester? And how do you name this? You name the R prime as the alkyl group it is in front, methyl. Now, the rest of the molecule, there's IUPAC way. And a number of years ago, I had a really sharp Chem 170 student, and that student came up with another method that works about 99% of the time, 95%, which is easier. Let's look at the IUPAC method first. Name the R prime bonded to the oxygen as an alkyl group in front. Now, if that R prime was hydrogen, name what you have left over as a carboxylic acid used to make that ester. And with that carboxylic acid, you drop the IC and the word acid and add ATE. So let's look at what we just did. If R prime was a hydrogen, this would be propanoic acid. And we're going to drop the IC and the word acid. And then add ATE. And that's methyl propanoate. Now, what the student came up with, which gives the same answer, except for one thing I'll explain later on today. If you look at the same thing, name R prime as the alkyl group it is, methyl. Then you count how many carbons are, including the carbonyl carbon, are in this part of the ester. And 3, that's propane. Drop the E and add OATE. And that's methyl propanoate, same answer. So I like the student's way, except for one example. And let me show you the one example where you have to use the IUPAC. That's when R is a benzene ring. Now, first of all, what functional group do you have here? And oxygen functional groups take priority over benzene rings. And if we look at this, we have a benzene ring, I'll call that R, carbonyl, oxygen, and then R prime. And this is an ester. And what's my R prime? Ethyl. Now, if you look here, what's the longest chain? It makes no sense because you've got that benzene ring. So now you have to use the IUPAC way. If this R prime was a hydrogen, that would be benzoic acid. Drop the IC and the word acid and add ATE, and you have ethyl benzoate. And the only time you can't really use the student's method is when R is a benzene ring. Other than that, you can use that method, and I will. This is easier. Actually, I can do both ways, but for you, it's easier. All right, let's try another one. Hang in there. I want to change my mind here. All right, let me do this, and then you know I'm going to share the fun. What's the IUPAC name for the following? Remember, IUPAC means official name for this molecule, 3 points each. And I should tell you, test number 3, when it comes up, will be like test number 2. It'll have general knowledge, nomenclature, reactions. And it'll have about the same point breakdown. What was it? 60, 35, and 10 approximately. I'll have to write it in the next 2 weeks. I rewrite it, but it's the same thing, similar I do every semester when I teach Chem 170. Let's take a look at this. What's different? Ooh, carbonyl, oxygen to that same carbonyl. Carbons here, carbons here. That's an ester. How do you name it? Name the R prime as the alkyl group it is, and that's N-propyl. And then using the student's way, 1, 2, 3, 4, 5. Longest chain with the carbonyl carbon, 5 carbons, pentane. Drop the E, add OHE, and you have N-propyl pentanoate. Now, it's time for a special gift from me, Dr. White. Remember, just a little gift. But if you have alkyl groups on the chain here, the carbonyl carbon is 1, you name it just like you've done in the past. However, that makes names of esters very complex. So my gift to you is this semester, any ester nomenclature, there will be no alkyl groups on the R of the ester, the straight carbon chain. That makes your life easier. All right, let's try one. And the question would be, give the IUPAC name for the following molecule. 3 points each. Your turn, then I'll do it. Thank you, Andrew. Thank you, Christiana. Thank you, the whole class. All right, let's do it. What do we see that's different? Ooh, carbonyl, oxygen with carbons on it, and carbons on that carbonyl. This is an ester. And how do we do this? We call this R prime, and we name it in front, ethyl. And now we can use that bright students method. 1, 2, 3, 4, 5, 6, including the carbonyl carbon, hexane. Drop the E, add OHE, and we have ethyl hexanoate. Oh, this is fun. We got to do another one. And here's another one for you to do. Notice R is a benzene ring, so you got to use the IUPAC method. Give the IUPAC name for the following. Thank you, Christiana. Thank you, Andrew. My turn. All right, what's different? Look for what's not carbon, what's not hydrogen. Ooh, oxygen here and here. And one's double bond to carbon. That same carbon has an oxygen. On that oxygen are carbons, I'll call R prime. On the carbonyl carbon, carbon double bond oxygen has a benzene ring, I'll call it R. It's an ester. And now how do we name that? Well, you name R prime as the alkyl group it is in front. And that's an isopropyl group, if I can spell it right. And then on this part, R is a benzene ring. Well, in that case, we have to use the IUPAC method. Think of R prime as a hydrogen. That would be benzoic acid. Drop the IC after benzo, the ic and the acid, and add ATE, and you get isopropyl benzoate. Dot my I there. And that's how you do it. And again, I will not, but before we do that, let's do something else. Oh, I did say I won't put an alkyl group on the R group of the ester. Now, something we talked about earlier, but I didn't talk about the nomenclature because I wanted to wait until I did esters, and that's this. And that's the carboxylate anion, where for this class, M will be sodium, lithium, or potassium. It can be other things too, but for nomenclature, that's all I'm going to ask you to learn. Now, how do you do this? It's similar to an ester. One, all right, so you name M plus as the element it comes from, like sodium, lithium, or potassium, and you put that in the very front. All right, now let's call method 2A in an ester. After you name the R prime, you use 2A as the IUPAC way, to be or not to be. That's the question. I couldn't reach this step. Anyways, B2 is the student way, and you use that to name the rest. So name M plus as the element it comes from. The rest, the carbonyl and the R group, named just like an ester. So let's take a look at this. Now, let's look at the molecule I just drew. What's different? Ooh, carbon, double bond oxygen, oxygen, ooh, a negative charge, and a cation. And this carbonyl carbon, carbons. This is a carboxylate anion. And let's go name it. What element has the chemical symbol K? And you should know that's potassium. So we'll put that in front. Then this part, we do like an ester. 3 carbons, propane. Since it's not a benzene ring, I drop the E, add OHE. And that would be potassium propanoate. And that's how you do it. Now let's look at this molecule. We actually already talked about this. If you look at this molecule, what's different? Carbonyl, oxygen with negative charge. Ooh, a sodium cation, I'll call that M+, and a benzene ring, R. Now, this is a carboxylate anion. And how do you name it? Well, what's the element Na plus comes from? Sodium. But now R is a benzene ring. We can't use the student's method. We'll use the IUPAC method. If that was OH instead of O minus Na plus, that would be benzoic acid. Drop the IC in the word acid and add ATE, and you get sodium benzoate. So that's how you name these. Now, time for you to have some fun. And here's one for you to have fun with. Seven carbons. Thank you, Andrew. Thank you, Christiana. Time for me to do it. All right, let's see if I'll get it right. The suspense, I hope, is not killing you. Uh-oh, it's bad humor slipping out. To Monday. All right, what do we have that's different? Ooh, carbon, double bond oxygen, oxygen on the same carbon with a negative charge, and a sodium cation. And I can abbreviate the sodium cation by M+, and it's got carbons on the carbonyl carbon. Remember, M can be lithium, sodium, or potassium. In real life, it would be other things, but for this class, I'll just keep it to this. We have a carboxylate anion. And how do we name that? Well, what's M plus sodium cation? We name that as front as the element it comes from. And then, oh, I can use the student's method. 1, 2, 3, 4, 5, 6, 7. Name that as an alkane, heptane. Drop the E, add OHE. Sodium heptanoate. Oh, let's do another one. And here's another one for you to try. Thank you, Andrew. Someone's getting the hang of it, like all of you. Doesn't that feel good? Everybody say yes. No, you don't have to. All right, my turn. What's different? What's not carbon? What's not hydrogen? Ooh, carbon double bond to oxygen, that same carbon oxygen with negative charge, and a cation, I'll call M plus, and I have a benzene ring. This is a carboxylate anion. And how do we name this? Well, you name the cation as the element it comes from. Lithium, Li. Next, well, I can't use the student's method because this right here is not a long chain. So I use the IUPAC method. If instead of O minus La plus it was OH, that carboxylic acid is benzoic acid. Drop the IC in the word acid, add ATE, and you get lithium benzoate. All right, now, the reason I had to teach you this before I did the other type of nomenclature question is the following. And the question is, draw the following molecule. Well, how do you do that? Well, organic chemical names, you start from the right, move left. Now, here's where you have to think. Well, you have to think the whole time, but something, pay attention. And that is OAT ending. That can be either an ester or a carboxylate anion. And how do you know? You look in front. If in the front of the name you see an alkyl group, it's an ester. In the front of the name, if you see a element name, it's a carboxylate anion. Well, this is an ester. If this were instead of OATE, that would be butane, 4 carbons. The end carbon, I'm going to do it always on the right. You can do it on the left, but I don't. Is a carbonyl with an oxygen. And because it's an ester, the first name tells me what R prime is, and that's 2 carbons. I know there are 4 bonds to carbon, so I can put in my hydrogens. And that's how you do it. So I better give you have one. And it's your turn. Draw the structure for ethyl oxenoate. Wow, it's a tie. Both of you finished at the same time, not that it's a race. All right, my turn. How do you decode this? Know what to draw? You start from the right, move left. OATE ending tells you it can be either an ester or a carboxylate anion. Well, our prime in front ethyl tells me it's an ester. If this were an E octane, 8 carbons. Including the carbonyl carbon. It's got an oxygen. What's our prime? Ethyl, 2 carbons. And now I know I have to put in my hydrogens. There's 4 bonds to carbon. And that's how you do it. Oh, let's do another one. I don't know, what letter am I on? C. And it's your turn. Draw the structure for sodium propanoate. Thank you, Christiana. Someone's getting the hang of it, like a couple of you. So I told you organic chemistry is fun. Thank you, Andrew. How do we decode this? We start from this end and OHC ending. It can be either an ester or a carboxylate anion. And how do we tell? We look in front. We have an element. If this were an E, propane, 3 carbons. Since it's a carboxylate anion, I have a carbonyl, oxygen minus, what's my M plus? Well, it's sodium, Na plus. Now, you don't have to show the charges. You could have put O and A, but I like to show the charges. I think it looks cool. Dr. White always wants to be a cool dude. I know there are 4 bonds to carbon, and there we are. Oh, let's do one more. And that one more is T-butyl benzoate. Draw the structure for that molecule. While you're doing that, I need to get a refill for my water bottle. I'll be right back. All right, everybody done? I'm back. full water bottle, so I'm ready. All right, Andrew, are you done? Give me a thumbs up if you're done. Thank you. All right, how do you decode this? Know what to draw. Start from the right, move left. OAT ending can mean either an ester or a carboxylate anion. How do you know which? You look in the front and you see, oh, I see an alkyl group. So if this were it doesn't work. If this were IC in the word acid, benzoic acid is this carboxylic acid, but it's an ester. Remember ester. And this up front is my R prime, T-butyl group. And that's T-butyl benzoate. And that's how you name esters. Oop, I forgot a slide. I'll have to do it the old-fashioned way. And now I remember why I didn't do a slide. Now, there's one common name ester I would like you to know. And first, let's draw the ester. And here's the ester. Now, the IUPAC name, remember ester, is this. Well, R prime is an ethyl group. And since I have two carbons here, I can call that ethane, but it's an ester, drop the E at OATE. And this is the IUPAC that nobody ever uses. Ethyl ethanoate. What's the common name that everybody uses for this ester? And the R group, just like before, is ethyl. Now, normally at this time, you would say, what's the carboxylic acid you would use to make that? And if R prime were a hydrogen, it would be this carboxylic acid. But the common name uses the common name of this carboxylic acid, if I can write it properly, is acetic acid. So to use the IUPAC way, but with the common name, use the common carboxylic acid, drop the IC in the word acid, and add ATE. And this is the name everybody uses for that structure, ethyl acetate. Other than telling students this is the IUPAC name nobody ever uses, I can't remember the last time I heard in a conversation with chemists ethyl ethanoate, ethyl acetate. I heard often. Now, as you can tell, I polish my nails not. Actually, back when I was a little boy, my father to some extent, but my grandfather, he went to barber shop. Most of the barber shops here in Chicago, the neighborhood ones, had manicurists in all of them. And they'd cut your nails, and then they'd put a clear coat for men of nail polish on there. But that's sort of come out of favor in the last couple of decades. However, women still polish their nails. And until about 5, 6 years ago, if you went to any big box store like Walmart, or as my friend always says, that French store, Target, otherwise known as Target, and he uses that every time. Let's go to Target, that good French store. But anyways, if you go to the area where they have nail polish remover, up to about 5 years ago, you'd see most of the bottles were ethyl acetate. Ethyl acetate is one of the two molecules that's used as nail polish remover. In the chemical industry, it's used for other things, but is one of its biggest uses has been for nail polish remover. However, a couple of years ago, maybe more than a couple, chemists, organic chemists, found a way of making a much more durable, stronger nail polish. And how many of you have seen the nail polish? You put your nails underneath the light, and all of a sudden it, I was going to use the chemical term, but it dries the nail polish. No, it doesn't really dry it. It cures the polymer. By the way, nail polish is very sophisticated organic chemistry, really is. But anyways, that is much more durable, I'm told, by students over the last couple of years. And because of that, ethyl acetate doesn't work as well to remove the nail polish. So now if you go into the stores, you'll find the majority of the bottle are nail polish with acetone, which you know what that is, a ketone. And next time, I forgot to do it. I made one of my last week rare pilgrimages to Walmart. I try and stay out of that place. It's dangerous. Just like I try and stay out of Costco. That's dangerous too for me. I can drop a bundle in both stores. All right. So this molecule you should know is ethyl acetate is the common name. And as I've done all semester on a test, I will never ask you, here's the structure, what's the common name? But I will ask you, here's the common name, draw the structure. All right, let's move on. All right, we've done our nomenclature. Ooh, fun part. Let's find out, where do you find nature's esters in nature? Well, the first thing, I bet you didn't know, which is why I'm telling you, esters, and this is stuff you should know, esters are responsible for the flavor and fragrance, how it smells, of many flowers and fruits and vegetables too, I could have added. Now, if you've ever smelled a banana, what you're really smelling, and this is a common name, pentyl acetate. If you've ever smelled a rose, the rose is a very sophisticated mixture of different esters. Here's some of them that have been identified. I mean, Mother Nature really did herself out on that. Now, perfumes are mainly esters. By the way, perfume chemists are some of the highest paid chemists in all of organic chemistry. I actually applied to a couple of companies, but I had different background in grad school, so I never got the job. And I'm sort of glad, because I'd have to move to the East Coast, like Givaudan and a few others, L'Oreal I applied to. But I got into the chemical industry, which has been quite fun. All right, so the next time you smell a perfume, what you're smelling is a complex mixture of esters. Now, you've done distillation. How do perfumes work? Well, most women put a little here and a little here, one of the places. Why there? Because your body heat vaporizes, causes some of the esters to become a gas, which you can then smell or someone else smells. And because they have slightly different boiling points, they come off at different rates, and that gives perfume its complex smell and makes it, the different perfumes very interesting. Now, earlier today, I said I'd tell you a story that I'm not too proud of, but I should tell it. When I was in high school, I had a God-given talent. He must have gave it to me to get my mother instantly upset with me boiling red upset to me. We've had some interesting clashes. And I know, if I remember correctly, a lot of my friends, boys, they had that same ability to get in trouble with their mother. All I had to do was say something, and for some reason it was the wrong thing to say. Well, whenever I'd get in trouble, my father would come home from work, my mother would yell at him, "Does your son did this and or said this?" And he'd come up to my room, and my father and I were very close. Close the door and he would say, "What the heck did you do now?" He didn't use those words, but similar. I'll keep my class clean. And he'd say, "Well, you know what you have to do now, don't you?" And I said, "Yeah." And what did I have to do now? I'd have to go to Marshall Fields, which is now called Macy's. If you're familiar with the Skokie, Lincolnwood area up north, suburbs, Old Orchard, and I don't know what they call, I think they still call it Old Orchard, is a huge shopping mall. And they had, back when I was in high school, one of the biggest Macy's other than downtown Chicago. I don't think Woodfield was even built yet at that point, or was just starting to be built. And I would go to the perfume counter of Marshall Field, and depending how mad my mother was, I'd have to buy her a bottle of her favorite perfume. And what was that? Chanel No. 5. After about a year or so, because the women behind the counter seen this high school boy come, "What are you buying this expensive perfume?" And I'd say, "It's for my mother. She's mad at me. This is how I get out of the doghouse." After about 2 years, when they'd see me come to the counter, they knew me by then. They'd say, "All right, what'd you say to your mother? What'd you do?" And the bigger the bottle, the more trouble I was in. And that stuff was not cheap, and today it's not cheap either. I do love that. It was so awesome perfume. If you look, I don't know, have you ever smelled Chanel No. 5? It's quite high end, and it's quite, hold on 1 second, maybe 2 seconds. Oh, look, a small bottle of 1.2, that's the spray, or they're all called, is only $90. Back then it was expensive too. 3.4 ounces, a bigger bottle, is almost $150. Like I said, she had very good taste in perfume. All right. Now, an interesting thing, you see on bullet number 2 right here, esters in nature have been used as sex pheromones by many animals. What's a sex pheromone? Well, I'm not an expert in animal husbandry, but I think you're all familiar with when a dog or cat goes into heat, they attract all the males in the neighborhood. You got to be careful. But anyways, how do they do that? Well, it turns out Mother Nature, who's a great organic chemist, came up with an idea. I assume she doesn't talk to me, but anyways, where when an animal is in heat, wants to reproduce, it gives off a chemical that attracts the male of the species. And that chemical is an ester. And dogs, cats, and many mammals give off esters as sex pheromones. And insects too. I think I forgot what insects they were able to attract all the male of that insect and kill them by using a sex pheromone for that insect. Well, for many eons, people, including scientists, have been trying to find out, is there a human sex pheromone? And the answer is so far, no. Every once in a while, you hear a story on the radio or TV. The last good one I heard was some scientist somewhere at some university or somewhere said, oh, we found the sex pheromone for humans, and that's male sweat, and that attracts females. Now, obviously, that hadn't caught on, because are you going to go down with your guy to the local, wherever you buy perfume, like Macy's or anywhere else, and say, have a bottle of sweat? No, I don't think so. But you hear everything. Now, the one thing that humans have mimicked animals is with perfume. Perfume is sort of a human sex pheromone because women wear it, one of the reasons, to attract men. And I don't know if you've seen over the decades, every once in a while, they repeat a certain type of advertisement for cologne for men. And how many of you are familiar with the cologne Axe? And Axe has a commercial where you see this guy, sometimes it's a nerdy looking guy, put on some Axe, and he goes outside, and all of a sudden all these beautiful women jump him. And the implication is this is a sex pheromone. It attracts the opposite sex. Now, that's been going on, that kind of commercial, for a long time. Back when I was in college, there was a product called Canoe, cologne for men, aftershave lotion cologne. Really, it's still a perfume. And you see the same thing. Nerdy guy puts on his Canoe aftershave, goes outside, and all these beautiful women jump him. And the tagline was, do you canoe? Go figure. Speaking about go figure, we're almost ready for another break. Time flies when you're having fun with esters. Now, in case I've been giving you a headache, this is the structure of aspirin. Switches off on this. And if you notice, aspirin has 3 functional groups in it: a benzene ring, aromatic, a carboxylic acid, and an ester. And this is aspirin. Yes, I know how to make it, but I have no idea how it eliminates pain in your body. But if I'm giving you a headache, you can always take an aspirin, and you know it's organic molecules. Now, before I go on to the next one, which we'll do after a break, let's do something real quick. All right, everybody see on your screen a chart with different esters? And we make it a little larger. There, I did. If you notice here, this ester is an apple. Sometimes they're in more than one thing, like another ester also is in apples. If we look at bananas, there's one ester, but there's another ester. That's the key ester. Don't find it right off. But if you look at octyl butyrate is in parsnip. I don't know, I haven't had a parsnip. Octyl acetate, which we've made in the lab, gives that orange fruity smell. And you notice pineapple, apple, and strawberry have one share same ester, And these are all esters we can smell from peaches or I don't see apples. So these things you taste and smell are due to esters. I went over, all right, let's take a 5-minute break, come back at 2:51. I'm gonna get up and stretch again. Time to get going. All right, we're talking about esters, and the next time you happen to, well, it's getting fall now, but in the spring when I go walking, I'm probably the only one in my neighborhood when you can smell all the flowers thinking, wow, esters. Now you know I'm an organic chemist. You haven't figured that out by now. Now, how do you make esters? There's only really one way, and that's called Fischer esterification. And Fischer esterification was discovered by the great German organic chemist, Dr. Emil Fischer. Now, this alone is a lifetime achievement, but later on we'll learn what he's really known for is his work with sugars and carbohydrates, but this alone is a lifetime achievement. So let's take a look at this reaction. How do you make an ester? You take a carboxylic acid, react it with an alcohol in the presence of acid catalyst, H+. And H+ can be something like sulfuric acid or acids I really won't discuss in this class, like benzene sulfonic acid and toluene sulfonic acid, even methane sulfonic acid. If you take an alcohol and a carboxylic acid, you'll get an ester. Now, the carbon in R prime with the hydroxyl group will be the carbon in R prime with the oxygen, the ester. Again, the carbon in R prime of the alcohol with the hydroxyl group will be the carbon in R prime of the ester bonded to that oxygen. So let's take this for a spin. All right, the question is, give the organic product or products for the following. Remember, these general reactions that I'm teaching you are building blocks that organic chemists use to make the things you use in your daily life. And I actually worked for a chemical company, at that time it was called Unichem Chemicals, that made esters. So if we look at this reaction, we've got two organic molecules. The first one, what's different? Carbonyl, hydroxyl group, R group, carboxylic acid. Second molecule, carbon, hydroxyl group, alcohol, and don't forget the acid catalyst. And this is Fischer esterification, and you'll make an ester. And what's R methyl? Actually, R is methyl. What's R prime? And propyl. So of my carbonyl carbon, R group is methyl. Remember, you don't break carbon, single bonds. Oxygen, again, you don't break carbon, single bonds. There are three carbons. Notice the N carbon is attached to the hydroxyl group. So the N carbon of three carbons will be attached there. Now, let's have you have some fun. And it's your turn to have fun. what would be the organic product or products for the following reaction? 3 points each. Thank you, Andrew. Thank you, Christiana. It's my turn. If we look at the first molecule, what's different? Ooh, carbon double bond oxygen, same carbon hydroxyl group, and on this carbonyl carbon, carbons, carboxylic acid. Second molecule, carbon hydroxyl group. Ooh, an alcohol. And acid catalyst, and this is Fischer esterification. What's my R group? Ethyl. What's my R prime? Ethyl. And now, what happens? Well, I have my 2 carbons R prime are still bonded to carbonyl carbon, oxygen. My R prime is ethyl, and I'll put in my hydrogens. And that's what you get. Oh, we got to do another one of these. And here's another one for you to try. Give the organic product or products the following reaction. And let me clean this up a little. That looks better. I just found out, everybody, I'll be teaching this course online next semester. If you know anybody who needs to take a 1-semester organic, feel free to have them sign up for my course this coming winter, which will be totally online. Thank you, Christiana. Okay, thank you, Andrew. All right, if we look at this molecule, what's different? The first one, 2 oxygens, it's the same carbon. We have a carbonyl, carbon double bond oxygen, hydroxyl group, and then attached to the carbonyl carbon, I have these 3 carbons. And what do I have? I have a carboxylic acid, R. And then the second molecule, carbon, ooh, oxygen with a hydrogen, we have an alcohol. Acid catalyst, and this is Fischer esterification, and we get this ester. What's my R group? These 3 carbons, carbonyl compound, oxygen, oxygen there. Now, remember, the hydroxyl group carbon in R prime is the carbon bond to oxygen in R prime in my ester. And that's this one. So I have my isopropyl group, and wow, that's an interesting looking ester. And there you go. Oh, let's do 2 more. And there you go. Give the organic product or products the following. Thank you, Andrew. Thank you, Christina. My turn. All right, first one, what's different? Carbonyl hydroxy group R on it. We have a carboxylic acid. Ooh, second one, carbon-carbon hydroxyl group. It's an alcohol. An acid catalyst to form an ester. And what's the ester? R is methyl. Carbonyl, oxygen, R prime is ethyl. And that's the ester we make. Now, I have a question for all of you. Can anybody see the significance of this reaction? Take a couple seconds, look at it. I'll even give you a few more seconds. What's the significance of this reaction? I'll help you out. Does that help? Not really. All right. My turn. What's the significance? Well, guess what? What if you were on a desert island and you needed nail polish remover and you didn't have any? Well, if you had some acetic acid and water, vinegar, some ethanol like vodka, and some acid, you could make your own ethyl acetate nail polish remover. One of the mental exercises I like to do is, what if I had to make that on my own? How would I do it? I like to do that for organic molecules, like if you were on a desert island or just you had to make it what you had at hand. All right, now on test 3, like test 2, I will have a couple synthesis problems. So let's look at the following. All right, what would be the starting materials, otherwise known as the reactants, in this case, 2 of them, that you react with acid to make that molecule? Your turn. Thank you, Christiana. Well, somebody's getting the hang of it. Somebody else is getting the hang of it too. Thank you, Andrew. Make me so proud of both of you. Thank you. All right, let's take a look. How do you determine what 2 compounds do I react to make this product? Well, you look what's different. I got a benzene ring, but it's attached to carbonyl, which also has a oxygen and has carbons here. This is an ester. And how do you make an ester? You react a carboxylic acid with an alcohol. And if we come back to our ester, this is my R group. And on the oxygen, this is my R prime. And once you have that, you know that my carboxylic acid would be benzoic acid. And my alcohol, R prime, is methanol. And that's how you make an ester. Now, esters play an important role in our life, and you'll learn later when we get into fats and oils, all fats and oils are esters, and we'll get into that later in the semester. So let's move on. Now, once you have an ester, what can you do with it? Oh, by the way, I'm not doing mechanism. If anybody's reading the book, I've skipped that. Hopefully you didn't buy the book because you really don't need it. It's an okay book. It's a good book, except it's missing good practice problems, which is why I had to make my own. All right, switches off. Just a little background. Everybody see on the screen lactones? Lactones are cyclic esters. They're made from hydroxy acids. And here's an example of a lactone. Let's take a look at this. Notice here I have, let me go to a different color ink. I have a carbonyl carbon, oxygen, carbons here, carbons here. This is an ester, but R and R prime are connected together in the ring right here. And for some reason, organic chemists also call this a lactone instead of a cyclic ester. Why? I have no idea, but they do. Now, let's click switches on. Let's talk about reactions of esters. The first one I like to talk about is acid hydrolysis of an ester, or ester acid hydrolysis. And you take an ester, react it with water and acid, and you get back the carboxylic acid and the alcohol you would have used to make that ester. So if I have an ester and react it with acid and water, or water and acid, remember H plus means an acid catalyst. And what you get back is the carboxylic acid plus the alcohol you would have used to make that ester. Now, one of the things I keep on asking, why are we learning this stuff? What good is it in my life? Well, this is one way you can make carboxylic acids from esters Mother Nature provides. We'll come back to this reaction because I work for a company that did something like this, or some of the reactions we'll talk about later to make carboxylic acids. Now, the other thing I would ask you, right now, where you are, where can you find right now acid and water? Real quick. Oh, water. And guess what? It just went into my stomach. And one of the miracles of life for me is I have and you have cells in your body that make acid, hydrochloric acid. And we'll learn later in the semester that this reaction I'll be going through is how your stomach and one of your intestines, I always forget which one, also has acid in it. I'm a chemist. Last biology I had was freshman year of high school. Not there's anything wrong with biology, but even by then I knew I wanted to be a chemist. Well, that's how your body breaks down fats and oils. using the acid and water in your stomach? Well, let's look at acid hydrolysis of an ester. Well, let me try something first before we do that. All right, let's have fun with this. And if you look on your screen, you see the reaction. And the question is, what's the product or products? And on a test, I would put something like this or just a plus sign. That tells you there are two things. Well, how do we proceed? We look at the starting material and say, what's different? Well, I've got a carbonyl oxygen on that carbonyl carbon, and I've got carbons attached to it. And the oxygen, I have carbons attached to it, and I have an ester. At this time, I still remember that student. As soon as I said we have an ester, she'd look at me like, "You calling me? What?" That was funny, not for her, but for me. Anyways, take an ester. We're reacting with acid and water, acid hydrolysis of an ester. What do you get? You get back the carboxylic acid plus the alcohol you would have used to make that ester. Remember, the carbon with the oxygen and the ester R prime is the carbon R prime with the hydroxyl group. I'll say that again in slow motion. The carbon with the, anyways, it's silly Monday, with the oxygen in the ester and R prime will be the same carbon and R prime with the hydroxyl group and the alcohol. Well, if we look at this ester, this is R prime. So the first molecule you'll get is this carboxylic acid, acetic acid. The second one, notice the oxygen's on the end carbon of 3 carbons. Do you break carbon-carbon single bonds? No. Oxygen-carbon bonds, yes, but not carbon-carbon single bonds. And that carbon will have the hydroxyl group. There are 4 bonds to carbon. So I'll put it in my hydrogens and I'm done. But now it's your turn. And there you go, your turn. And while you're doing that, I worked for a company for a number of years that one of their major product lines was in making esters. One time I was at their headquarters in the Netherlands. They're having problems making esters quality wise in a plant in England. And next thing I knew, the CEO found me. I was in a meeting and said, tomorrow I want you to go to the city. It was right outside of Manchester. I want to say Chester or Littleborough, one of those two, and say, go solve this problem. And by then I was known as a problem solver and things like that. And the next morning I was on a plane to England from the Netherlands. It was like an hour trip. And went to the plant and did what I was supposed to do, solve their problem. Everybody done? Okay, what's different? Anybody have any nightmares hearing me say what's different, what's not carbon, what's not hydrogen? Well, it works for me every time. I've got an oxygen, double bonds is carbon, carbon, oxygen here. On the carbonyl carbon, I have carbons, R, And on the, oh, I forgot to put the plus there, sorry. On the oxygen, I have carbons R prime. And what do I have? An ester. What am I reacting with? Acid and water. And what do you get back? You get back the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. And now, what's our 3 carbons? Carbonyl, OH. I have this carboxylic acid. What's R prime? Ethyl. That's this alcohol. And that's how you do it. Now, as I said, there'll be some synthesis problems on test number 3 coming up in a couple of weeks. Boy, do you realize this is already week 9 of 16 weeks? We're more than half done. Wow, time really does have fly when you're having fun with organic chemistry and Dr. White. All right, let's try a synthesis problem. What would you react with acid and water to make these 2 molecules? Everybody's done, so it's my turn. And how do you do this? You say, what's different here? Carbonyl hydroxy group, carbon, a carboxylic acid. What's different here? Carbon, carbon hydroxy group, and alcohol. And the question is, what do you start with to make a carboxylic acid and an alcohol by reacting with acid and water, acid hydrolysis? And the answer is an ester. In this case, what's our methyl? Carbonyl, oxygen. What's our prime? It's an ethyl. And there's how you do it. Anybody see the significance of this reaction? Everybody give up? All right. What's this? Ethyl acetate. That's the common name. Nobody uses that IUPAC name. And what's this? Acetic acid. Started writing the acid before acetic. And this is ethanol. And if you were trapped on that proverbial desert island and you had a lot of nail polish remover, ethyl acetate, and some acid and water, you could make acetic acid, which you could make vinegar for your salad dressing, and ethanol. You could have a good strong drink too with your dinner. And that's the significance. See, I think in different ways because I'm an organic chemist. Well, it's always an interesting mind game I play. What if I need these things? What could I use to make them? All right, let's move on. Uh-oh, hold on. All right, back in business. Something tells me I'm going to try this Wednesday to close out and reopen my whiteboard. I think that's where I'm having the problems. All right. All right, let's get back to work. Remember, next time you go into a florist shop, whatever you're smelling, remember you're smelling esters. All right, let's talk about the next reaction. And this is called saponification of an ester. It's also base hydrolysis of an ester. And it's a key organic reaction. Oh, come on, Dr. White. You say all the reactions are key. They are, but this was important. And we'll learn later on this semester, not now. It's a way of making soap. The old way, our ancestors, or if you use a bar soap, this is used to make that, or can be. Now, what is that reaction? And here I have ester-based saponification. I don't test on names. It could also just be called the saponification of an ester. Now here we take an ester, react it with water and a base. Now, I have sodium hydroxide. We can do other bases. So let me write that on a whiteboard. Where M can be sodium, potassium, or lithium. It can be a lot of other bases too, but let's stick it to that. And we
Dr.
have,
White, we're still on the slide.
yeah, I forget to change. Now can you see it?
Yeah.
Thank you, Christiana. All right, let's do this again. Take an ester. Can you see it? Everybody give me a thumbs up if you can see it. Thank you. All right. And you reacted MOH is different bases. Thank you, Andrew, too. M can be sodium, potassium, or lithium. And what you get is not the carboxylic acid you would use to make that ester. You get the carboxylate anion of the carboxylic acid to make that ester plus the alcohol. Now, the question is, how come? And let's take a look. This is one of the rare times I'll do a sort of pseudo mechanism. When you hydrolyze that ester, you'll get the carboxylic acid plus the alcohol. But you notice I have it in brackets? That means you can't isolate it. Because remember, a carboxylic acid reacts with a base and water, and this is an acid base, and this goes directly to the carboxylate anion. And the fastest reactions in all of chemistry are what's called diffusion controlled. As soon as two molecules come together, they react, and acid-base reactions are the diffusion controlled reactions. So remember, if you put down the carboxylic acid, it can't exist in the presence of base. I'll mark it wrong. So let's take this reaction and try it. All right, everybody see the reaction? Thank you. All right, so the question is, what's the organic product or products for the following reaction? And if we look here, what do we have that's different? Well, I've got carbons to carbonyl, carbon double bond oxygen, oxygen here, carbons here. This is an ester. KOH, that's a base, which I can write like that. Water, I can write like that. Remember, M can be sodium, potassium, which in this case it is, or lithium. And what do we get? We get two things, and I should have put a plus there. And we have not the carboxylic acid, but because we're in base, the carboxylate anion of the carboxylic acid used to make that ester, plus the alcohol used to make that ester. Well, here's my R. Here's my R prime. So I'm going to write my two carbons right here, R. I have a carbonyl, but now I have the carboxylate anion. And what is M? Potassium. Now you don't have to show charges, I will. And there are 4 bonds to carbon. Am I done? No, we have this alcohol to deal with, and that's from R prime. And that's how you do it. And this is a reaction. Actually, I worked for a company that started the previous reaction, this one, back in the late 1700s, using this to make candles. And so, I don't know if I told you, the company I worked for, Unichem Chemicals, we made fatty acids and their derivatives, which are from fats and oils. I'll tell you this again later on, but some of our big customers were personal care companies. How many of you have heard of the company Neutrogena? And they bought fatty acids, carboxylic acids, to make into different products they use or sell. All right, let's have you have some fun. And here's some fun for you. And I should tell you, we're right on track in the syllabus. Things are going good, which makes me happy, and hopefully you're happy about that. Thank you, Andrew. Thank you, Christiana. My turn. And if we look at this, what's different? Ooh, oxygen double bond to carbon, carbonyl. Oxygen to that carbon with carbons on there, I'll call R prime. Carbons on the carbonyl, I'll call R. And what do we have? Oops. Too many R primes. We have an ester. And then here, lithium hydroxide, LiOH, that's a base. And water, remember M can be sodium, potassium, or in our case, lithium. And what do you get back? The carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol you would have used to make that ester. So based on that, R is 3 carbons, my carbonyl, and don't forget, this is a carboxylate anion, and I was about to write sodium, and that would have been wrong. Lithium, cation, and then my R prime, 4 carbons. Notice the N carbon of this N-butyl group is attached to the oxygen of the ester. So my alcohol will have the N carbon here. And that's how you do it. And what would you react with sodium hydroxide and water to make those 2 molecules? And this is a synthesis problem. Like I said, there'll be 4 or so on test number 3, which this material will cover. Thank you, Andrew. Thank you, Christina. Wow, you guys are really getting the hang of it. I should say, I'm being sexist now. You people are really getting the hang of it. All right. I could also say you students. All right, let's take a look at this. What's different? Ooh, carbonyl, carbon double bond oxygen. It has an oxygen with negative charge and a cation, M plus. It's got carbons here, I'll call R. Ooh, carbon hydroxyl group, alcohol. I'll call this R prime. And what do we react with? A base, MOH, plus water. Remember, M can be, in this case, it is sodium, potassium, or lithium. In real life, it can be other things too, but I'm going to stick to that. And what do we start with? An ester. And what's our methyl? Carbonyl, oxygen. What's our prime? Methyl. If you take this ester, you'll make this carboxylate anion that alcohol. If I look at the clock, we're just about done. All right, don't forget, my office hours are now Tuesday and Wednesday from 6 to 6:15. If you were not able to come to today's today's meeting, I'm going to be cutting out where I went through the answers for test number 2. And if you can't come to my office, if you can, come there and I'll be more than happy to discuss any problems on test 2 so you know the right answers. Or if you can't come to my office hour, always feel free to email me and we can set up something on Zoom. You don't have to drive to ECC. And with that, I'll say stay warm. It's cold out there and windy. And I'm done for today. I'll let you out a whole 30 seconds early. Actually, I don't even have to do this. I could just show up for 2 hours a week, I was told. That's not right. And you'd be on your own. That's not right. With that, I'll say, gang gesund. Goodbye. I stole that from Granny to Beverly Hillbillies. Bye now.